In this video, we will introduce the basic differentiation rules. First, let's consider the constant function f of x equals c. Right? Again, c is a constant, so it's a real number. F prime of x, limit as h goes to 0, f of x plus h minus f of x all over h. Well, this is going to be the limit as h goes to 0 of c minus c over h, which is the limit as h goes to 0, 0, and that's just 0. So the constant rule for any real number c, the derivative of c is equal to 0. Before we look at our next rule, we need a result from algebra, specifically the binomial theorem. Which states for any real numbers x and y, and any positive integer z, any positive integer n, x plus y to the nth power is the summation I equals 0 to n of this number, x to the n minus I, y to the I, right, where this here, this ni, is n factorial over I factorial times n minus I factorial, and it is called the ni binomial number. It is also denoted b sub ni. With this, we can now consider the function f of x equals x to the n for any positive integer n. Now, it's important to note that while this derivation is only going to be for positive integers, the result holds for any real number n. So this will hold for any power of x. So f prime of x, using the definition, this is where the binomial theorem needs to come in. So this is going to be the limit as h goes to 0, summation I equals 0 to n, and I'm not going to write it that way, sorry, I'm going to write it b sub ni, x to the n minus I, y to the h to the I. Now minus x to the n all over h. If I is equal to 0, then b0i, or I'm sorry, bn0 is going to be 1. Okay? So what's going to wind up happening is this is going to become the limit as h goes to 0 of x to the n minus 0, which is n, plus now we continue the sum. Now we start at 1 because we just pulled out the I equals 0 term. Right, and the whole reason to do that was so we can cancel out these x to the n's. Now, if we notice, since I starting at 1, every term in this sum has an h, so we can factor an h out. We'll be left with h to the I minus 1. That allows us to now cancel out those h's. And this is now what we're left with. Once again, let's go ahead and take out I minus the I equals 1 term. If we do that, we'll have b sub n1, so the n1 binomial number, x to the n minus 1, h to the 1 minus 1, which is just 1. And now we're left with a sum. I equals 2 to n now. If you now notice, every term in this sum has an h. So as h goes to 0, this entire summation will go to 0, right? It's just the sum of a bunch of zeros. So this is what we're left with. All that's left to do now is to evaluate what the n1 binomial number is. So it'll be n factorial over 1 factorial times n minus 1 factorial. 1 factorial is just 1. By definition of factorials, n factorial is n times n minus 1 factorial. And so this is nx to the n minus 1. So the power rule states that for any real number n, the derivative of x to the n is nx to the n minus 1. Again, while the derivation that we just did was assuming n was a positive integer, the result actually holds for all real numbers n. We now consider this function. G of x equals c times f of x for some real number c. So we're taking the constant multiple of a function f. Specifically, constant multiple of a differentiable function f. So if we take a look now at g prime, Again, using the definition of the derivative. Recall from pre-calculus that this is just c times f of x plus h minus c times f of x. Now we can factor out that constant c from the numerator. Now we can factor out that c from the limit. And what you should notice is that limit right there is f prime of x, since f is differentiable. So this is the constant multiple rule. Let f of x be a differentiable function. And let c be any real number. Then the derivative of c times f of x is equal to c times f prime of x. So the derivative of a constant multiple of a function is the constant multiple of the derivative. The last type of function we're going to consider in this video is this function. Let's call it k of x, f of x plus or minus g of x. So we're going to look at the sum or difference of two functions where both f and g are differentiable. So we're looking at the sum or difference of differentiable functions. All right, so k prime of x, limit as h goes to 0, k of x plus h minus k of x all over h. Again, this is just from the definition of the sum or difference of functions that was studied in pre-calculus. Now what we can do is group this however we want. So let's group it this way. We'll have f of x plus h minus f of x, then plus or minus g of x plus h minus g of x all over h. And we can write this now as two fractions. There's our first fraction, and then plus or minus our second fraction. We can then write this as the sum or difference of the limits. Like so. Now, this first limit is simply f prime of x because f is differentiable. And that second limit is simply g prime of x because g is differentiable. So this is known as the sum difference rule. So let f of x and g of x be differentiable functions. then the derivative of f of x plus or minus g of x is f prime plus or minus g prime. So the derivative of a sum or difference is the sum or difference of the derivatives. Now, throughout all this, you should have noticed that when you take the derivative of a function, the result is a function. Right? Specifically, if you take the derivative of a function f of x, then its derivative is a function of x. So we can take that derivative, can't we? Let's write it this way. So we can take the derivative of f prime of x. So this can be represented in two ways. F double prime of x, or d squared dx squared of f of x. This is known as the second derivative. Well, then it makes sense that we can take the derivative of this. This would be f triple prime of x, or d cubed dx cubed of f of x. This is the third derivative. So on and so forth. So in general, we have the nth derivative. So that would be the derivative of the n minus first derivative. Right, so nth derivative, or d sub n, I'm sorry, d to the n dx to the n of f of x. Collectively, these are all known as higher order derivatives. We will conclude this video with two examples. What we want to do is, given f of x equals x squared minus 4x plus 6, we want to find the tangent line at the point x equals 1. So recall that we had point slope form y minus y naught is equal to m times x minus x naught. Well, m is the derivative. So we can write this as y minus, let's call it f of x naught, is equal to f prime of x naught times x minus x naught. And if we solve for y, f prime of x naught times x minus x naught plus f of x naught. This is the equation of a tangent line of a function at a point x naught. And this is the general equation. So from now on, we can just plug everything right into here. And that's what we're going to do here, right? So y is equal to f prime of 1 times x minus 1 plus f of 1. Now, f of 1. One minus 4 is negative 3, plus 6 is positive 3. We just have to find f prime of 1 now. So f prime of x. So for this problem, I'm going to write it all out. So first we see some difference, so this will be d dx of x squared minus d dx of 4 times x plus d dx of 6. d dx of x squared is the power rule, so that's 2x. We have a constant multiple, so this is 4 times d dx of x. And then the constant rule says that d dx of 6 is 0. So d dx of x is just 1. So we're left with 2x minus 4. This means that f prime of 1 is negative 2. So our tangent line, negative 2 times x minus 1 plus 3, negative 2x plus 5. So this is our tangent line. Okay. And next, given that f of x is 3x to the 5th minus 2x squared plus 7x to the minus 2, we want to find f triple prime at negative 1. So first we're going to need f triple prime of x. To do that, we have to calculate the first derivative. That'll be 15x to the 4th minus 4x minus 14x to the minus 3. Now we need the second derivative, which is the derivative of the first derivative. 60x cubed minus 4 plus 42x to the minus 4. Now we can find the triple derivative by taking the derivative of the second derivative. 180x squared minus 168x to the minus 5. Now we just plug negative 1 in right there. We have 180 plus 168. And we find that f triple prime of negative 1, is 348. Alright, so that concludes this video. In the next video, we will introduce 2 more rules, the product rule and the quotient rule.